يعطيكم العافية طلاب الأعزاء. راح نكفي أنا وياكم شابتر 1 ويفز. بالفيديو الماضي عرفنا الفايبراتوري موشن وأعطينا الكاركترستيك للفايبراتوري موشن، وكان بآخر الفيديو في عنا 2 ابليكيشن راح نحلهم سوا مع بعض. الابليكيشن نمبر 1 عم بيقول لي في عندي the adjacent figure shows a spring as and then we release it, we stretch the spring and then we release it. The spring oscillates making 15 oscillations in 5 seconds. بيقول لي part 1 what is the nature of the motion of the spring؟ أن spring perform vibratory motion justify because it is to and fro motion about fixed point. بيقول لي calculate the frequency of this motion. أن الفريكونسي هي number of cycles per unit time، يعني number of cycles or oscillations during interval of time. number of oscillations هو 15 والتايم هو 5 second، والتايم هو 5 second، فإذا n 15 over 5 3 Hz. بيقول لي deduce the period. عرفنا البيريود هي التايم needed to complete one cycle. البيريود هي 1 over frequency يعني 1 over 3. ال SI unit للبيريود هي second. application number 2 عم بيقلنا pendulum. قلنا الباندولوم هي عبارة عن واير، وفي بطرف الواير ماس M is shifted from its equilibrium position and then released from point A as shown in the adjacent figure. جينا شديناها from equilibrium position وعملنا لها release، صار تعمل swinging. Which point correspond to the equilibrium position of the pendulum؟ أي point هي equilibrium position؟ equilibrium position هي point C. point C هي equilibrium position. Which points correspond to the two extreme positions of the pendulum؟ هن ال A وال E. ال A وال E هن extreme position وأبعد نقطتين بتوصلن الباندولوم. عم بيقول لي the pendulum oscillates 10 times in 2 seconds. واضح من الجيفن إنه 2 seconds هي التايم وال 10 times هي النمبر عدد ال oscillations. define frequency. قلنا frequency مرة الماضية هي number of cycles per unit of time. بيقول لي calculate its value. نحن بنعرف الفريكونسي هي النمبر over time، يعني عدد ال oscillations على قديش بدهم وقت. عددهم هن 10 والتايم هو 2، وقلنا ال SI unit للفريكونسي هي هرتز، 5 هرتز، يعني 5 cycles per second، يعني 5 oscillations بالسكند. بقول لي deduce البيريود. نحن قلنا البيريود هي 1 over الفريكونسي، يعني 1 over 5 يعني equal 0.2 second. بيقول لي what is the time taken by the pendulum to move from A to C؟ قديش بدها وقت لتنتقل من ال A لل C؟ قلنا البيريود هي التايم taken to complete one cycle، يعني إذا بلشت عند ال A لتروح لعند ال A ولترجع لعند ال A، هي البيريود. فإذا البيريود هي لترجع لنفس النقطة identically. فإذا من ال E لل A هي نص البيريود T over 2. فإذا ال C هي الهاف، هي الإكوليبريوم بوزيشن. فإذا من ال A لل C هي T over 4. ببارت دي عم بيقول لي what is the number of oscillations performed by the pendulum in 10 seconds؟ كم oscillation بيعمل بال 10 seconds؟ احنا عرفنا انه بال 1 second بيعمل 5 oscillations لانه الفريكونسي هي number of cycles per second. بدنا نيجي بنحط الفورمولا F equal N على T. نحن بنعرف الفريكونسي هي 5، نحن بدنا number of oscillations يعني بدنا ال N، ومعطينا التايم هي 10. فإذا ال N equal 5 times 10 يعني 50 oscillations. بنكفي نحن وياكم بدرسنا اللي هو الويفز. هلا رح نعرف شيء اسمه periodic motion. عرفنا vibratory motion، هلا periodic motion. البريودك موشن هي الموشن that repeat itself identically in constant interval of time called period. يعني هي الحركة اللي بتكرر حالها بنفس كمية وقت. مثلا الأرض بتفتل حول نفسها كل 24 ساعة تعمل 1 rotation. فإذا the rotation of Earth around itself is a periodic motion. مثلا الكلوك الارمز بيتحركوا. المينت arm بده 60 minutes to return to its position. So the arms of the clock also is periodic motion. الwaves light قلنا هو example على الويف، قلنا كمان الساوند هو example على الويف، قلنا seismic wave that cause earthquake also example of wave. Or there is a common between all these waves that they transfer energy or propagate energy. يعني نحن بس نقعد ما قبل الشمس بنحس بالدفء، الدفء هي طاقة. The earthquake caused destruction. This destruction is due to energy. فإذا all waves carry the same property. They propagate energy when they transfer. هلا الميكانيكال ويف، شو هي الميكانيكال ويف وشو هو اللي بيعمل الميكانيكال ويف؟ الميكانيكال ويف هي ويف أكيد carries energy but it needs a medium to propagate. يعني مثلا when we throw a stone in the pond it creates a wave where the medium of this wave is water, so the wave transfer or propagate through water. Sound, when we talk the sound propagate through air. فإذا a mechanical wave is a disturbance or oscillation that travels through matter. فإذا a mechanical wave it needs medium to propagate. It transfers energy from one point to another through a medium. This medium may be solid, liquid, or gas. We will see you in next video.
Continue what we have learned before about the periodic and the vibratory motion, and we talked about some characteristics about the vibratory motion, which are the amplitude, the frequency, and the period. Today we are going to start about waves. Now, by definition, a wave is a moving vibration, or it's the propagation of vibration, which means that if you have particles that are vibrating, they will create a wave. This wave transport energy and do not transport matter, which means that each particle in this wave do not move, it only transport energy, and the particle only vibrate in its same place. This is a very important note about waves, that transport energy only and do not transport matter. The characteristics of a wave. There is a common characteristics of a wave between a vibratory motion and between a wave. The common characteristics are the three: the amplitude, period, and frequency, that are represented by A small letter, T capital letter, and F small letter, that we discussed in session number 1. The two characteristics that we are going to add for any wave that we have is the wavelength and its speed. Now let's look at this figure in here. In this figure we have a representation for a wave. Now we know that the highest point, which is the peak point or the highest point in a wave, we will call it the crest, and the lowest point in here we will call it the trough. And let's draw a line, and this line will represent the equilibrium position of this wave. Now, this is the crest, this is the trough, and this is the equilibrium position. We know that the amplitude is from the equilibrium position into the crest, or into the highest point that we have. The amplitude is a positive value. Now, what is a wavelength? A wavelength is the distance covered by the wave during one period or during one oscillation. So when this wave covers one complete oscillation, we can say that the distance it covers is the wavelength, which is represented by a symbol called lambda. This is the symbol lambda. And since it represents distance, then its SI unit must be meter. Now, to find the value of this wavelength, using the graph that we have, we can measure the distance between any two crests that we have, or between any two troughs that we have. For example, we have, this is the first crest and this is the second crest. If we measure the distance between the two crests, we will get the wavelength lambda. Or this is the first trough and this is the second trough. If we measure the distance between those two troughs, we will have the wavelength lambda. Also, if we draw the equilibrium line like this, we know that whenever you have a section that we complete one oscillation, we can say that this is the distance is the wavelength. For example, to complete one oscillation, you need to have half of the wave is below the equilibrium position and the other half is above the equilibrium position. Now this is colored in black, is one complete oscillation, so this distance will be the wavelength lambda. You can also measure it from here. Let's say that we started at this point. The one complete oscillation, half above the equilibrium position and half is below the equilibrium position. So the distance from here to here is the wavelength lambda. So every place that you cover one complete oscillation is the wavelength lambda as a distance. The fifth characteristics that we have for a wave is the speed, where the speed is the ratio of the distance covered by the wave by its time, or it's the distance covered by the wave per unit time. Now to find the speed of the wave, we can use one of the three formulas that we have in here. Either we can say that the speed is equal to the distance divided by the time, or it's the wavelength divided by the period, or it's equal to the wavelength multiplied by the frequency. The speed is symbolized by V small letter or capital letter, and its SI unit is meter per second, which means that the distance must be in meter and the time must be in second. The wavelength must be in meter, the period must be in second, the frequency must be in hertz. So to obtain a speed in its SI unit, every value that we are using must be in its SI unit. Now, let's say that we have a representation for a wave and we need to find graphically the value of the wavelength and the period. To find the values graphically, we first of all must look at the x-axis. The x-axis must be one of the two options. Either it's time, t in second, which will help us to calculate the period, or the same x-axis in another graph, suppose this one in here, must be x in centimeter, let's say, and this will help us to calculate the wavelength. Now, if we have the representation as x in centimeter, it will help us calculating the wavelength. And if we have it t in seconds or time, it will help us to calculate the period. To find the value of the period and the wavelength using these two graphs, we must complete one oscillation. And we said before, to complete one oscillation, you must look from a crest to a crest, where crest is the highest point, like this. This is the first crest, this is the second crest. Since it's x in centimeter, this value between the two crests is the wavelength, which is represented by lambda. Now, if we look between one trough and another, it's also between of them is the wavelength lambda. If we start from this point, half above the x-axis and half below the x-axis, or half above the equilibrium position, half below the equilibrium position, and this is the wavelength lambda. The same if we look at the second representation where we have t in seconds or time, then we know that we are going to calculate the period, which is represented by t capital letter. To find the value of the period from a crest to a crest, the time between those 2 points is the period t. We can look from a trough to a trough, the value is the period t. And if we start, let's say, from this point, half below the equilibrium position, half above the equilibrium position, which means that this time between those 2 points is the period t that we need to calculate.